Hello everyone, this is example 2 from section 8.4. A company claims that the standard deviation of the lengths of time it takes an incoming telephone call to be transferred to the correct office is less than 1.4 minutes. A random sample of 25 incoming telephone calls has a standard deviation of 1.1 minutes. At alpha equals 0.10, is there enough evidence to support the company's claim? Assume the population is normally distributed. First of all, the claim is about a standard deviation. That's how I know I'm going to try to do a chi-squared test. A chi-squared test has two conditions or requirements. Need a random sample, check, and the population must be normally distributed, check. Next, to perform a hypothesis test, you go through the same 5 steps. So first, identify your hypotheses. Since we want to know if it's less than 1.4 minutes, that is going to be our alternative hypothesis and also our claim. Then our null hypothesis is sigma equals 1.4. Step 2 is to draw a picture. And since this is a chi-squared test, I'm going to draw a chi-squared distribution, which is non-negative values and right skewed. Since the alternative is less than, this is going to be a left-tailed test with the area equal to 0.10. Notice how I'm writing it above the graph because it represents the area, not this cutoff value. Step 3. Calculate our chi-squared test statistic, which is n minus 1 times s squared over sigma squared. N is 25, so n minus 1 will be 24. S is 1.1, so we have to square that. And sigma, based off the null hypothesis, is 1.4, so we have to square that as well. After sticking this in a calculator, we get 14.82 as our test statistic. Next, I'm going to calculate the critical value. The critical value is the cutoff associated with this area. In order to find a cutoff associated with an area, we have to use inverse chi-squared. Now when you do inverse chi-squared, you need the area to the left if you're on a TI calculator, but we need the area to the right if it's a Casio calculator. So if you have a TI calculator, because the area is to the left, you would put 0.10 in. If you have a Casio calculator, the area to the right is 1 minus that, because we want the remaining area. So that would be 1 minus 0.10, which is 0.90. And I will use the Casio directions for these notes. So that's 0.90, comma, and then you need degrees of freedom, which is 24. When you do this on your calculator, you should be getting 15.66. So this cutoff value is 15.66. Our test statistic, 14.82, falls right there. Since chi-squared star falls in the rejection region, we reject the null. Since we rejected the null, that means we support the alternative. And since the alternative was our claim, that's why we're going to support our claim. So there is enough evidence to support the claim that the standard deviation of the lengths of time it takes an incoming telephone call to be transferred to the correct office is less than 1.4 minutes. And that's it for example 2.